Hello, everybody. This is Pete from PA Labs. And well, we're going to pick up on the regular expressions and carry it to the next level, more of an advanced kind of class. If you look over here on the right of my screen, there's a lot of regular expression commands, okay? And I want to get to some of those because those are the kinds of things that make regular expressions in code quite powerful. The ability to find the expression match length and position and match string and the named groups and all of this sort of stuff. And the ability to do the replace regular expression. That's pretty cool too. Although I don't know that I have an example of that yet, but I will by the time I publish this. Okay, so I want to look at the named groups. Named groups is a really cool thing in regular expressions. It allows you to write a query or write an expression that returns a named thing, okay? Because once it's named, normally you can do stuff with the name. So here, we're somewhat limited. Other applications and other tools let you do a lot more, but I mean, every language has its implementation. So your naming structure begins with a parent and ends with a parent, and you have a question mark and then the less than, greater than, and the name is in between that less than and greater than. All right. So that identifies a named group. And I've seen everything from just the number one. Sometimes I've seen the number two. Sometimes they just say name. And you're like, huh? What's the name group name? But okay, it doesn't matter what you call it as long as, I mean, this is yours. And I want to point out that your expression is here, but this can be part of the expression that begins out here. Okay, so you can drop a named um, a group name thing into just about anywhere in your expression. So what they're doing and what I picked up on here was one of the group, I think it might even have been the regular expression group example. And I decided that, well, they did it, but it really, it's kind of a weird one, but it's okay. It shows you some things that you can do, which is great. So what we're doing is our group name is column, COL, color, I guess is what that stands for. And the expression that they put in here is red or green or blue. The pipe identifies an or condition. Okay. So what they're saying is, come down here and let's look at the whole expression of the regular expression. You have look for the exact literal. Remember, there's no brackets, there's no nothing. It's looking for anywhere in a sentence, in a chunk of code. If he comes across lower case sensitive, COLOR equal, okay, he's going to go, hey, let's check the other side of that equal sign. And if it's red or green or blue, then our named collection, our color group will then contain the value of whatever it is. Okay. Now, I guess you could have written this differently because it's not going to pick up black and it's not going to pick up yellow or magenta or any of the other colors in the rainbow. Another way I guess this could have been written would have been color, color, doggone it, OLOR equals, all right, and let's go ahead and put this in quotes. And then what we could do is the whole we're going to catch it thing. and let's call it color. And we could say A to Z, A to Z, 0 to 9, and then a lot of times it includes a dollar sign, but in order for that to be a dollar sign, I've got to escape it. And then we can say square, and we can say any number of those guys and close. Okay? That way, whatever is on the other side of color equals. Now notice I did not include the comma. So I'm expecting a comma, a space, or something to truncate my grabbing. I'm going to grab everything of case and numbers, uh, any number of them. So if somebody wants to put in the color code from a color picker over here, it's going to come in as dollar sign, blah, 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 blah. I'll even pick that up and return that back as the color, okay? His query here is specifying we're only going to find a match if it's these three. So just, you know, thinking out of the box to try to make things um, more inclusive or what have you. So that is how this reads. And so what I've done is come into here and said, okay, let's print a bunch of junk off. Let's reprint our text. Let's reprint our regex. We're going to create an array for the results. Because in all honesty, we could have another one out here on the far right. If this is a great big line, you may return 2 of those or 5, or you may be spinning through a whole bunch of lines, and kind of like I do on the little regex expression tester guide that I wrote. And so now what I'm doing is saying, let's capture some stuff. Okay, so what's our match position? Okay, so first we're creating our regular expression 0, and we're passing it the regex. Then we're telling him to examine, kind of like you do in the file system guide, and you got it, and then you've got a while next regular expression match. He's going to loop that while to here, and then he's going to sit here and do this while he's got expression matches. So we're going to come down and say, okay, our regular expression, let's get our match position, let's get the group length. So then I'm going to echo those back on our debug panel. And then let's go ahead and grab the expression named group position and the length of the named group, okay? So the hope here is that he's going to return this B through the length of 4 here, okay? Now, you kind of have 2 different positions being identified. Where is the regular expression match position? And I believe that is going to match the color, the C, and then the group match is going to match the blue, okay? And the question is that going to match inside this expression? And does this match inside the entire length of this? So that's where I started this. And then we got the group length. And so I said, okay, here's the group position. Here's the group match length. And then, okay, result. This is what he's matched to. So we're spitting back the match. And then we say, okay, the color is the regular expression name group. So that's the actual name. He's spitting back the value found for this name. So in this sentence, that's going to spit back blue. Okay. Now, the match text, and check this out. We're going to do a mid text matched position plus the P, which is the regular expression name group. And then since these are all just normal numbers, you adding those together, that's going to get you actually one byte too far into our sentence up here. When you start counting from here, that's going to bring you to there. Okay, so you got to subtract one, which is kind of like a zero base subtracting one. I don't concern myself too much with that. And then the 4, well, actually, I think I could have used this L over here and just used the instead of that. So let's see what we get as results from running this one. Okay. Okay, so the string to test was this. Our regex that we're running is that. The match position is 13. See, there's the 4. I could have put in the L down there. And then our group position is 7. So if I started counting from here, 1, 2, 3, 4, 5, 6, 7, that's the 7th character. Okay. And then he's capturing the 4 starting at 7. Okay. So there's that one. The starting position, the match position for the letter C of the color, which was our regular expression match, is from here to the beginning. Well, actually, it includes the C. So that's the 13. Okay. So you're able to derive the exact points of where in the text things were found. Okay. And then we have, okay, the color is blue, and that was returning the value of COL, our group. And then match text of being blue was me deriving it down here with a mid text. Okay. So that's pretty cool in my book. Okay. Think of some of the things, the ramifications of what you can do to a text based solution. If somebody's got text and they want to slice it up, or they want to do mass changes to things, um, you can go about searching enormous volumes of text with regular expressions and doing this sort of thing. Take, for instance, if you were, you know, getting deposition texts from people's depositions, and you want to search through the entire deposition text, you could use regular expressions really quick to identify every reference of a certain spelling of a word, or all that kind of stuff quite easily, and then return back the points in which it was actually stated in whole sentences, and you could do some pretty neato things. So that's one. Okay. And then the next set that I did basically the same kind of thing, except my thinking was I'm going to create my group name as group, and there's no preamble to my regular expression. What I was trying to do is go through a block of code and pull out all the form names, let's say. Okay. So what my regular expression is saying is find me everything that begins with lowercase frm, and that you've been following these, you know I prefix all of my form names with frm, and then it's a name. I rarely ever, if ever, I can't even remember the last time I used a number in a form name. That's just inappropriate. So we could actually scream through the code like this. And if you thought about it from the perspective of this application doing this, he could scream through whatever. I could paste an entire code sheet in the top, put that expression down here, and I'll get a list of all the form names down here. Now, if you're doing this in code, you could actually do a call with every single, let's go back over here, with every one of these he finds, he could make a call to a procedure that adds a distinct list. So he then takes the name, spins the list. If it's not found, adds it, and if it is found, disregard it. And at the end, it spits back a distinct list of names. And throw in a sort so you can spit them back in alphabetical order. Uh, if you wanted to track the position in the sheet where they were found, you could do that. There's a lot of stuff you can do. It does have, oops, I forgot to put comments on this. All right, hold on. I was blocking those off and putting names in and lining stuff up that made sense. So this pretty much does the same kind of code as the last one. He's going to come back and say, this is what we're looking for. I want to find anything that begins with lowercase frm, and then comes back with a name. And so it kicks back the regex tester. Okay. So, and I can match to it in code. Now, we could just as easily come into this, and there is this replace regular expression, and it's just a simple sentence that you're in here and you're running this. You do your create. When you do the execute, you then say, okay, regular expression, here's my regular expression number, here's the string we're reading. So if you're iterating through that whole great big list of names, he then immediately does a replace string to anything you want to do in there. And presto, you've just now changed the code. Okay, you've changed the source string. Normally you would do this and have your source separate and then spit it all out to the result screen, so you can test and retest, get it right, and then put it into your code and go for it. But that's how you would actually do the replace. So if you're looking for, say this is in a Stencilla sort of environment, or even a RTF environment where you're actually in an edit control and you're monitoring what is being typed. When they hit a space to change names, you count backwards in the code to find the last word, and then look at that word up against a list of words, special words. Then you might want to change its color or change its case or something like that. You would use this regular expression, replace regular expression command, that sort of thing. So regular expressions are really neat. They're very, very powerful. They're very Unix in that they do not ask if you really want to do this. It's done when you finish hitting the enter key. It's kind of like using the VI editor. The VI editor is the same concept. And they when I was at Marathon, just a little side story, we had a project that had some really cool acronym, and within 2 weeks it had changed names to Operation Phoenix, because it was our first venture into the Linux Unix world, not Linux, Unix at the time. This was back in the late 80s. Early 90s, late 80s, early 90s, right around there. And about the only editor that existed back then was VI. And so somebody would type delete del star, hit enter, and take out the entire hard drive. Okay. In the VI editor, if you type every case you can come up with for the letters del means something differently. If you type lowercase del, that means you're deleting files, okay? And if you say star dot, it says, look at the current tree, delete everything that comes before this folder. And if you do a dot star, it says, from this current folder position, delete all the folders downstream of this guy. So basically, del star dot star meant completely destroy the hard drive. All right. And that happened so many times in the first 6 months of this project because it was a bunch of DOS programmers that they threw on the project. And oh my God, it's like they were restoring that system from tape every 20 minutes there for a while. It was really bad. But in the VI editor, every case you can come up with, capital D, lowercase e, capital L is something different. Capital DE, lowercase l was something else. Capital D, lowercase el was something else. Every permutation of capitalization of DEL meant something different in the VI editor. And there is no such thing as are you sure? It just goes and does it. Okay, if you got permissions, it's done. So yeah, it's I actually have a shirt that says don't do this from home, delete star dot star. So that's a throwback directly to that environment. So anyhow, this pretty much concludes what I wanted to show you in regular expressions. There's a lot of tools. If you find yourself loving regular expressions, there's a lot of great tools. There's a product called regex buddy that's out there that you can use. There's a lot of editors that support regular expressions in searches and in replaces. There's all kinds of stuff. And we have only touched on some of the characters you can use, the lowercase a dash z, all of that kind of stuff, pipes, carets, dollar signs. There's probably 200 or 300 different characters that all have different meanings, and putting them together make whole different sentences. If you find yourself ever in an environment where you're doing heavy duty text type searches, then your answer is regular expressions. Remember that it exists. So that concludes this video. And as always, thank you very much for watching.